Good morning, my dear friends. Welcome back to my YouTube channel. Today I am going to solve a Leetcode problem on March 16th. Leetcode problem is minimum time to repair cars. It is in the medium range of problem, which it requires some mathematical operations to solve this problem. Let us see what this mathematical approach to solve this problem. Now let us see the problem statement. What is the problem statement given is, you are given an integer array of ranks representing the ranks of some mechanics. We are given an array of ranks in which every index represents the rank of the particular ith mechanic. That means, suppose for example, given example is ranks are 3, 1 ranks. That means this 4 represents, this index or 4 represents the 0th mechanic rank. 0th mechanic rank. 0th mechanic rank. Simultaneously, this all represents the particular index represents the particular mechanic rank, and we a mechanic with a rank R can repair n cars, that in R into n square minutes. That means for a mechanic to repair a car, he takes R into n square of minutes. N square of minutes. R into n square of minutes. You are also given an integer cars, which represents the total number of cars waiting in the garage to be repaired. We are also given with cars. Let's suppose in the given example 10 cars. Here we should find that minimum time taken to repair all the cars. Here we should find out we have given the ranks of the mechanics and the number of cars to repair. We should find the minimum. It is the keyword. It is to find out the minimum. It is a keyword, minimum time. Minimum time. Now, from this, here they have given that a mechanic can repair in R into n square of minutes. Here, a mechanic can repair R into n square of minutes. Let's suppose x is equal to minutes. X is minutes. Now, to find out the number of cars, that means each mechanic does some work now. To find out, each mechanic does some number of cars. Let's suppose these cars be n. Now find out from this equation, find out the n is equal to x divided by particular r. X divided by particular r into under root. This is the value of number of count. That is number of cars. This is number of cars. We should find out the number of cars, and one mechanic can be able to do. Now we should find out the minimum time. We should find out the minimum time required to repair all the cars. That is, how can we approach to this problem? Here we should find out the minimum number of cars. So let us suppose the minimum time would be 1. Let's suppose minimum time required is 1, and maximum number of time is equal to rank of the particular person into number of cars into cars, because they have given for a particular mechanic can do work of R into n into n. Similarly, let's suppose the maximum number of time would be R into cars into cars. R is rank of particular index. Rank of particular index. This rank is highest number. That is highest number in the rank array. Rank array. highest number in the rank array. Let us take an example and try to solve this example. Now we should find out the minimum number of array, minimum time required. For this, we can go through from previous 3 days the same problem, the same keyword have been asking. What is the minimum time? What is the minimum time? What is the minimum time? We can go through an approach called binary search. Binary search approach. Here they haven't asked that particular target element. They have asked the target element as minimum element. That is binary search in range. We should find out the binary search in particular range. Here minimum time is 1. Maximum time is r into n square. This is the particular range of elements. To so on. Given example is, let us see an example. Given example is 4 2 3 1. Given example is 4 2 3 1. Given cars is equal to 10. Now we find left element, that is left is equal to 1. What would be the right? Right element is maximum of these elements. I think all of you know that how to find out the maximum number in an array. By using that, we find out the maximum element. Here the maximum element is 4. 4 into number of cars, 10 into 10. That is 400. Now this is the maximum element and this is the minimum element. Here to find out the minimum element, there can be a minimum of 1 and maximum of 400. Within this range, this minimum time will be situated. Now how to find out the minimum element? Here the condition is while left should be less than or equal to 0. Left than or equal to right. This is the condition for the binary search. Every question in the binary search starts with this condition. That is left should be less than or equal to right. Here left is less than or equal to right. Now we calculate the middle value. Middle value can be calculated in 2 ways. That is left plus right by 2, and left plus right minus left by 2. Left plus right minus by 2. This is the optimal way of calculating the middle value. It is the normal way. We calculate the mid and we check if this mid is the maximum value. No, it is the whether it is the minimum value. If function we call is suitable, it is a function which is used to check whether the given mid or calculated mid is satisfied in the as the maximum element or not. If it is satisfied, we check for the lower values. That means if suppose 50 is the calculated mid, 200 is the calculated mid, we check whether it is correct or not. If it is correct, we check for the still minimum value. We calculate whether it is we check in this range. If it is returning false, we check in this range. It is true, it is satisfied, so we calculated in this range. To calculate these elements, for calculating these elements, we do right is equal to mid minus 1. That means we can divide the elements. divide the element array. Here now it becomes right. Here it will become right. This is mid, and we keep result as mid value. We store the result as mid value. Now, if it returns false, if it is returning false, if it is returning false, we calculate in this range. That is left is equal to mid plus 1. Left is equal to mid plus 1. Left is equal to mid plus 1. This is the binary search approach. Now let's see how we calculate this is suitable function. How we return this is suitable function. Is suitable function is calculated, that is within the range how many number of cars can be repaired. We calculate the within the range how many number of cars or how many number of cars time can be calculated. We can calculate in this range. We check from the it is the is suitable function. Is suitable takes rank, cars and mid value. We calculate number of count variables, that is number of cars can be repaired. Long count is equal to, let's suppose long count is equal to 0. We for calculating, that is for summing of the number of cars, we use this approach called initially we take a variable and keep this variable as 0, and for every variable, for every element in the rank, we increment the count variable int of r in rank, that is rank. For calculating of the number of, that is number of cars, for calculating of number of cars, we take under root of mid divided by r. That is, this n can be treated as count. Number of cars can be calculated. I previously have discussed why we are going to solve this. This is minimum value. Through this, I have came to know that number of cars, how many number of cars within the time can be completed, within the mid value can be completed. If count is greater than or equal to mid, that means count number of cars is greater than or equal to mid value. Maximum of mid values, only mid number of cars can be repaired. If it is greater than, we return this, and we check for the condition. If it is within the range, we calculate the still minimum value. If it is within the range, we calculate the, that is, this is the correct answer. We have got the minimum value. So we calculate if there are still any number of minimum value, we calculate the still any number of minimum value, we calculate. For this, if it is returning true, it goes through this right is equal to mid minus 1 and result is equal to mid. If it is else, left is equal to mid plus 1. We calculate in this range. If it is returning false, no, it is not the minimum value, still we have the minimum value, we go through this range. Here the main intuition for solving this problem is understanding of this statement. We calculate how we can calculate the minimum number of cars that each repair or each mechanic can take is the main intuition for this problem. Let us see code. The code is similar. I have discussed pseudocode here. It will be in the syntactically. That is here. You can see that initially left. left is initiated with 1 because the minimum, right is initiated with integer dot minimum value. That means here we calculate the maximum element in the array, maximum element in the array, and we initiate right as n into r into n square. That is, r is the maximum element into n square. We have given in question r into n square. Long result is equal, initially result is given as right value. Here binary search approach, and this we call a function called if it is suitable within the range, it is suitable. If it is returning true, it returns the value, or else it goes through the range of maximum elements. So here, so this is the problem solution, and this is the brute force approach to solve this problem. Thank you, my dear friends. Subscribe to my YouTube channel. Hope this solution made easier to all of them. Thank you.